Basically, we are going to discuss these commands, find, tar, and gzip, how to deal with a directory structure. So let's say we have a project, and project will typically be a directory structure. You will have multiple directories. For example, a structure may look something like this: src for source files. You will keep all the .c files here. Maybe include for header files. You will keep all the include files here. When we compile using GCC, object codes are created, .o files. Maybe we create obj files in that obj. Maybe we create multiple executables, we keep them in binary folder. Let me create some dummy files. I will go in src and I will create empty files, a.c, b.c, c.c, d.c. So I have created 4 files here. I will go to include and I will create the same. Normally in the code structure, often you have this thing, a multi-file program. In engineering, you always have multi-file programs. You never write everything in one file. So for every .c file, the corresponding declarations you can put in the corresponding header file. So if you have a.c, b.c, c.c, d.c, you might have a.h, b.h, c.h, d.h. And in the obj, naturally, you will have the same O files, object files. And in the binary, hypothetically, we have created exec1 and exec2, which are two executables. So now I have a structure here. We can visualize it like this. We have these 4 directories, and in bin, I have executable, and in include, I have header files, and in obj, I have the dotos, and in src, I have this. But this was a very tedious way to visualize the structure of my folder. A easier way is simply find dot. So find basically searches in the directory structure and gives me the selected folders and files. For example, I can say find dot minus name star dot c. I am finding files. Where am I finding them? In the directory rooted at current directory. Instead of dot, I can give some other directory path also. I can say find slash also if I want to search in the entire root directory. And then I'm saying that find all the files which match this criteria, that the name of the file should be something.c. I get these. Let us say I have forgotten the path of exec2. So I can say find dot minus name exec2. It will remind me that this is the path. You can give some other directory also. Like for example, you can say find slash home slash vikas python. In that directory, find all files starting with DC. So there is none. All files starting with D. Yes, there are a lot many. So when I say dot, dot has nothing special. Dot just means the current directory. You can give some other directory also, and then you can give criteria. One criteria is based upon the name of the file. Other criteria could be based upon modification timestamp also. That what are the files modified in the last week? You want to maybe control them, git check in them or backup them. Another use of find is find dot enter. You have not given any criteria. When you have not given any criteria, it selects all the files and all the directories also. This is really showing the complete tree. You are at dot, then there is a bin directory. Within the bin, you have 2 files. There is a include directory. Within the include, you have 4 files. There is a obj directory, and so on. Two more things I will just tell. Let's say you want to email this entire project somewhere else. So if you say find project, now I'm at the parent directory of project. So I need to say find project. But you want to send all of it to somebody else. You need to create one archive. Archive is basically a bundle. What you can do is you can say tar minus x vf project dot tar. Project, it should be minus cvf. Let me run it. When you do ls, it creates a tar file. This is exactly what we wanted also. We wanted to bundle the project into a archive which we can email. And what is this minus cvf project.tar? This command is same as if I write it like this. There are 3 options. Minus c. Minus c is for compress or archive. V is for verbose. It was verbose. It was telling that what am I inserting into the archive. Minus f means this is the tar file. minus f has a argument that this is the tar file. In Unix, some options are without arguments. Minus c, minus v, that's good on its own. But when we say minus f, that means that I am telling the tar file name into which you have to write this. And now this project.tar can be emailed. So let me assume that it has been emailed, and I will create a directory in /tmp abcd, and I will assume that from the mail I have downloaded it in /tmp/abcd. I have copied it there. So now I am in /tmp/abcd, and somebody has sent me this tar file. What is this /tmp directory, by the way? It is a area for storing temporary files. Many processes create temporary files here, and these files are periodically cleaned up by the Linux system itself. Now the question is, how do I expand it? How do I get my files back from this archive? So the command is very similar to what we did. Command is simply this. Instead of C, you write X, and you need not give any directory. So tar minus xvf project.tar. X is standing for extract. And when you run it, because it was verbose, so it gave this output. Structure has been restored. If you say find project, it is telling you that all the files are existing. So now tar has only done this thing. It has bundled the directory structure into one file. And when you untar, that means tar minus xvf, it unbundles it. That's all. It doesn't really save space. It doesn't really compress the bytes. So many times tar is used in conjunction with, there is a command gzip, and I can say gzip project.tar. So I'm saying here is a file, zip it. Any file can be zipped. I'm zipping tar file. No news is good news. It succeeds, and it replaces that tar with a tar.gz. So this is a zip archive. So how do I use it? I first need to unzip and then untar. So my process is like this. I do tar and zip. The reverse process, I first unzip, I get the tar file back, and then I do untar. I unzip with the same utility, gzip. I can say gzip minus d for decompress. Unzipped. Now I can untar. I can say minus xvf project.tar. So this is how to deal with project structures which are nested.